Okay, today we will learn the cohesion and coupling of software design, of software decomposing the module in the high level design. The cohesion is a measure of functional strength of a module, and a cohesive module performs a single task of a function. On the other hand, the coupling between two modules are the measure of degree of interdependence on interaction between the two modules. So here this is coupling between two modules, the interdependency between modules, and this is the cohesion, that is the functional strength of the whole module, that if this module perform a single task or function. We have so far discussed the effective problem of decomposition is an important characteristic of a good module, of a good design. The good module decompose is indicate through high cohesion of the individual modules and low coupling of the modules with each other. The cohesion is a measure of functional strength of a module, whereas the coupling between two modules is the measure of the degree of interaction between two modules. So coupling, intuitively we can think of coupling that the two modules are said to be highly coupled if they are following these two things, that is they share data, the modules are tightly coupled. If the interaction occur through some shared data, then also we can say that they are highly coupled. So in case of couple, the two modules should be share some data. To understand cohesion, let us first go through the some ideas why the high cohesion and low coupling is necessary to us. Actually, if a module having high cohesion and low coupling, then we call that the functionality of independent, they are functionally independent of each of others. A functionality independent module needs very little help from other modules and therefore has minimal interaction with other modules. So we have, our target is to make our module functionally independent. That means if it is functionally independent, then the cohesiveness is high, and if the module is independent, then the interaction between multiple modules are very low. That is, the coupling is very low. So this is our target, high cohesion and low coupling. Now these are the following advantage if we make our modules in high cohesion and low coupling. The first one is error isolation. Whenever an error exists in a module, the functional independence reduces the chances of error propagation to other modules. The reason behind this is that if a module is functionally independent, then the interaction with other module is very low, and therefore an error existing in the module is very unlikely to affect through the other module's functionality. So as this module is functionally independent module and the interaction between these two modules are very low, that's why we will look forward to go to make our modules in high cohesion and low coupling. So the error isolation is very easy. Further, once a failure is detected, the error isolation makes it very easy to locate the error. If we got a error, so it is very easy to locate the error. And when a module is not functionally independent, once a failure is detected in a functionality provided by the module, The error can be potentially in any of the large number of modules and propagated to the functioning of the module. So if there are high coupling or the low cohesion, in that case these functionalities may have effect into other modules functionalities, and the low coupling means there are heavy data interaction between these two modules, and in that case in any problem or any failure in this module may affect to this module also. So this is the error isolation. The next point is scope of reuse. Reuse of a module for the development of other application becomes easier. Obviously, the reuse is very easier, and the reason of this is a functionally independent module performs some well-defined and precise task at the interfaces of the module with other modules are very few and simple, and a functionally independent module can therefore be easily taken out and reused in a different program. So if this module is functionally independent, and this module you may take from this project to another project if this module is very much necessary. In that case, as this is the independent module, so the dependency is less and you can move this easily from one to another. That will not affect to other programs, other functionalities or other modules of the program. On the other hand, if a module interacts with several other modules or the functions of a module perform very different tasks, then it would be difficult to reuse it. If this module interacts with different modules, so you cannot reuse this module easily, or you cannot move this module from one project to another project easily. So this is especially so if the module access the data internal to other modules. In that case, this type of this type of project is not suitable for us. And the last point is understandability. When modules are functionally independent, if modules are functionally independent, then the complexity of the design is greatly reduced. Then the complexity is reduced, that it is independent module. This is because of the fact that different modules can be understood in isolation. That means in isolation you may understand different modules, no need to necessary to understand this module with the help of any other module. Since the modules are independent of each other, we have already besides this there are we have listed we have listed here the three advantages. Beside this there are so many advantages of high cohesion and low coupling, but these are the many important for your software engineering. Next, the classification of cohesion. The cohesiveness of a module is the degree to which the different functions of the module cooperate to work towards a single objective. Different modules of a design can possess different degree of freedom. Okay, the cohesiveness increase from coincidental to functional cohesion. That is, cohesiveness increase from coincidental to functional cohesion. That is, the coincidental is the worst type. Here the coincidental is worst type and the functional is the best type. So first we will discuss what are those classes, different types of cohesions, and then we will discuss which one is the best, and then we will easily understand which one is the best and which one is the worst. So first, coincidental cohesion. A module is said to have coincidental cohesion if it performs a set of tasks that relate to each other very loosely. In this case, that means there is a module and there are set of tasks. Someone is print bill, someone is create user, delete user, show result, etc. So in this case we can say that the module contains a random collection of function. Someone it prints bill, some it prints the user, it creates the user, sometimes it deletes the user, sometimes it shows the result. It is likely that the functions have been placed in the module out of pure coincidence, okay, rather than through some thought of design. Without thinking anything of the design, these functions appears here through a coincidence. By chance they came to this here. The design made to novice programmer often possess this category of cohesion, and since they often bundle functions to modules rather arbitrarily, an example of the module of the cohesion we have shown here, and this type of cohesion is called coincidental cohesion. So when you are figuring out all these functions, your target should be that the similar functions will be into a single module. But here by all the different types of functions appears in this module. That is, this type of cohesion is called coincidental cohesion. And the second one is logical cohesion. A module is said to be logically cohesive if elements of the module perform similar operations. If all the elements of the module perform similar operations, such as error handling, data input, data output, etc. So, if we change this module, we can use one module for print bill, we can use one module for create user, we can use one module to delete user, we can use one module to show or display items. So, print bills, print other information, all will be into a single module. Create user, create database, create books information, etc. will be from into a single module. All the delete information of the books, maybe books, maybe membership, maybe user, etc. will be into the separate modules, and all the displaying values, show results, show book, display book, search books, etc. maybe into some different modules. So if we do this, then this type of cohesion is called, it is the logical cohesion. The logical cohesion consider a module that contains a set of print functions to generate various types of output reports such as grade sheets, salary slips, annual reports, etc. The third type of cohesion is temporal cohesion. Temporal cohesion. When a module contains a function that are related by the fact that these functions are executed in the same time span, then the module is said to possess temporal cohesion. That means if the functions of a module is executed in the same time span, then this type of module we call this is temporal cohesion. As an example, consider that when a computer is booted, several functions need to perform. So these include installation of memory on device, loading the operating system, etc. When a single module performs all these tasks, the module can be said to exhibit temporal cohesion. Other examples of modules having temporal cohesion are following, like similarly a module with exhibit temporal cohesion if it is comprises following perform installation, startup, shutdown, this may be in case of temporal cohesion. That means when the computer is booted on, the operating system will be loading, the memory will be loading, all the devices are giving some input data, all all other tasks will be done into the single time span. So if you put these functionalities into a single module, then you call that module is temporarily cohesive module. Next is procedural cohesion. A module is said to possess procedural cohesion if the set of functions of the module are executed one after the other. Though these functions may work towards entirely different purpose and operate on very difficult data, on very different data. Consider that the activity, so what we have told, if a set of functions of a module are executed one after other, and these functions may work towards entirely different purpose and operate on very different data. That means in a procedural cohesion, all the functions in a module should work one after another, and each and every function will work on different types of data. In that case, we will say that this is a procedural cohesion. The function login, then place order, then check order, then print bill, then place order on the vendor, then update inventory, and then last logout. All do different things, but if you put these different tasks into a single module, then this is called procedural cohesion. What is the example? Suppose you are going to log in. First, to order something, you are going to log in. Then you are placing an order. Then checking order. Then print bill. Then suppose here is the last. Then log out. So these all are different functionalities of a procedure, of a full procedure or full algorithm. So, and these procedures output is the input of this procedure. Login output of the login is the input of the placing order. Output of the placing order is the input of the checking order. Output of the checking order is the input of the print bill. Output of the print bill order is then the input of the logout. So the whole procedure is is the combination of different functionalities. If we put these functionalities into a module, then this module is called procedural cohesion. And look at that this function will work on different data, this function will work on different data, this function will work on different data. That means each and every function works on different data. So this type of functionality cohesiveness is called procedural cohesion. The next one is communicational cohesion. A module is said to have communicational cohesion if all the functions of the module refer to or update the same data structure. If all the functions of the module refer to or update the same data structure. For example, consider a module named student in which different functions of the module such as admit student, enter marks, print grade sheet, etc. access and manipulate data stored in an array named student records defined within the module. Suppose we have a module and we have to the functions available in this module is admit student, enter marks, print grade. So suppose these three functions. All these functions will update a single data structure. It may be a array, it may be some structure of C or C++, it may be some records in Pascal, etc. If it is, then this type of cohesion is called communication cohesion. That means all these functions are communicating into a single data structure. That's why it is a communicational cohesion. The next one is sequential cohesion. A module is said to possess sequential cohesion if the different functions of the module execute in a sequence. The different functions of the module execute in a sequence. And the output consider the following situation, that is, in an online store, consider that after a customer request of some items, it is first determined that the item is in stock or not. In case if the function create order, then check item available, then place order on vendor are placed in a single module, then the module would be said sequential cohesion, because that function create order creates the order that is possessed by the function check item availability, whether the item are available in the required quantity in the inventory, and is input to the, also it is an input to the place order on the vendor. That means suppose I am giving you the function that create order. This is the first function, and then check items availability, and then place order. So if a user creates an order, then this availability function will check that this item is available in our stock or not. If it is available, then it will place order. If it is not, then we will call the place order, and the place order said that this is not present. So this is called sequential cohesion. Now it is looks like the procedural cohesion, but it is, the difference is, in a procedural cohesion the whole process is a procedure, but here it is a part of a procedural cohesion. The whole procedure is not written here, because there is a login step, there is a logout step, there is a billing step, etc., etc. Those steps are not said here. So this is called sequential, and in sequential also the output of the previous one is the input of the next process. Output one the for previous process is the input of the next process also. So this is called sequential cohesion. Then functional cohesion. A module is said to possess functional cohesion if different functions of the module cooperate to compute a single task. Different functions of a module cooperate to compute a single task. In that case, we said that this is a functional cohesion. For example, a module containing all the functions required to manage employer's payroll. It displays the functional cohesion in, for example, suppose compute overtime, compute over time. The next one is, suppose, compute work hour. Okay, this type of tasks are done for a single function, a single task of a module. That's why these functionalities are in the we called that this type of module in functional cohesiveness. That means these type of different functions of module cooperate to compute a single task. So these were the all these seven classification, seven types of cohesion. And so you understand now that which one is the lowest of cohesion and which one is the highest sign of cohesion. In the coincidental cohesion is never for the lowest type of is not the high type of cohesion, because in the coincidental module all the functionalities are not related to each other. On the other hand, all the function in the functional cohesion, all the functions are cooperate to each other and performs a single task. So this, if these functions perform a single task, then this whole module are independently work. There is no relation between others. That is, in case of sequential, a part of the whole procedure are stored into the sequential process. So this sequential process is dependent on the whole procedural or any other sequential process. Okay, so so the functional type of cohesion is the best way, that is the highest order in the cohesion to implement, and that's why we should design our we should decompose our modules such a way. Next one is type of coupling. The coupling between two modules indicates the degree of interdependency between them. If two modules interchange a large amount of data, then they are highly interdependent or coupled. We can alternate state this concept that the degree of coupling between two modules depends on their interface complexity. The degree of coupling between two modules depends on their interface complexity. That means if the interface increase, the degree will increase and it is a low level coupling. If the degree of interdependency increase, the coupling increase, and this is a high type of coupling, and we should avoid this high type of coupling. We should do our modules independent modules. If these are independent, that is the relation, the interdependency becomes less, and we can reuse our module in different programs or different projects also. Sorry, this is mistakenly done here. The first type of coupling is data coupling. Data coupling. Two modules are data coupled if they communicate using any elementary data item that is passed as a parameter between these two. That means two modules are coupled together, that means interact with each other by pass some parameters between these two. If parameters should be integer, a single integer, or float, or character, etc. by passing some value. So this type of coupling we called data coupling. These data items should be problem related and not used for the control purpose. These data items only to related to each other, not to control the data, not to control anything of this module. So these data item only passed to by the like as a passed by value, and this type of coupling we called the data coupling. The next one is stamp coupling. Two modules are stamp coupled if they communicate using a composite data item. Composite data item example like records in Pascal or structure in C. These are the composite data items. That means these two modules are interact with each other with some structure, not simple, not primitive data structure, not primitive data. It will work on some complex data or some user defined data structure. Okay, so this structure or record or file, if these two modules are communicate with such type of data items, then we can say that this is stamp coupling. The third type is control coupling. Control coupling exists between two modules if data from one module is used to direct the order of instruction execution in another module. I am saying again, if data from one module is used to direct the order of instruction execution of another module. Suppose in this module there is a flag variable and these two modules are interact with each other, and depends on this flag variable, this module will work either this work or this work. That means this flag variable controls this module. Again said, this module controls this module, because depending on this flag variable, it may be 0 or 1, this module will work either this part or this part. That's why it is calling control coupling. This type of coupling is called control coupling. Next, common coupling. Two modules are common coupled if they share some global data items. Two modules, here are two modules, and suppose there is a global data items, suppose X file, and these two modules share these same global data items. This is a data items, not the module. This is the module 1, module 2. These two modules share this global data item or interacts. This module updates these data items, and this module takes data from these data items or updates these data items. This module may check these data items. If these global data items are considered by these two modules, in that case we said they are common coupled. And the last type of coupling is content coupling. Content coupling exists between two modules if they share some code. Content coupling exists between two modules if they share codes between these two items. Suppose this is a module and the if something condition, and this if block is written here, and this is another module, the else part of this if condition is written here. Clear? Here is a module, the if part is written here, here is a module, the else part is written here. So if we do this type of, and so they are interacting to each other, and if we do this type of coupling, then we called that this is content coupling. Okay, so the different types of coupling are shown here, and the degree of coupling is like best to worst. The data coupling where the minimum interaction is done, and content coupling where a maximum and complex type of interaction is done. That's why this type of interaction is very worst problem, is very worst case, and the in data coupling is the best case. That is, we are creating, we are coupled, the modules are coupled together by using some uh, value at the very pass by value, actually pass by value, and here it is they are coupled together with the part of the program. So it is not our target is data coupling. So you can understand now that high cohesion and low coupling is very much necessary to when we will module our problem, when we decompose our problem. Thank you very much.